Welcome back to the second part of 14.1. So I decided to break this into two parts because yesterday we were just talking about the graph y equals sine of x. We were just talking about this one on top, y equals sine x. It starts at the origin, goes up to 1, goes back through the x-axis, goes down to -1, back up to 0. That's a complete cycle of y equals sine x. Of course, we talked about we can change the amplitude and the period to make it look a little different. However, it always has this basic form. And today, the only difference is we're going to graph cosine of x, where the most basic form, it actually starts at 1. So cosine of 0 degrees, or cosine of 0 radians, is 1. Cosine of 90 degrees, or pi over 2, is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is +1. So this graph is almost exactly like sine of x, just look, it's like shifted over to the left by 1, because sine of x is really from here to here, and cosine of x is really just that graph shifted over. So they're very, very similar, and graphing them is also going to be really easy because it follows all the same rules we talked about in the first video for the chapter. So just like we talked about with sine of x, y equals sine of x, we can adjust the graph with a and b. So yesterday we said if we put an a in front, that changes the amplitude. That's half the distance from the very top to the very bottom. That's the amplitude. So the amplitude is just the half the distance from the top to the bottom, not the whole distance. And we can adjust the period if we put some b in front of the x. The same thing's true for cosine. Today's lesson is really just an extension of the last time. So we're just changing a, amplitude, and b, which changes the period. So in order to graph a cosine function, you really are going to find 5 points. But these 5 points are a little different from the 5 points you found for sine. So the 5 points you're going to find here are going to be the 2 intercepts. With sine we had 3 intercepts. For cosine we only had 2 intercepts. And those intercepts are 1/4 times 2 pi over b, which you'll determine, comma 0, and 3/4 times 2 pi over b, comma 0, which you'll also determine based on the problem. You're going to graph 1 minimum, which is 1/2 times 2 pi over b, negative amplitude, whatever that is, negative a, so if there's some number out front. And you're going to graph these two maximums. You're going to graph 0 amplitude and 2 pi over b, which is the same as the period, and the amplitude. However, this makes a lot more sense when we look at an example, so let me clear this up and get an example for you. It says graph y equals 1/2 cosine of 2 pi x. The first thing we need to do is determine the amplitude and the period. Here the amplitude is the absolute value of 1/2, the amplitude is 1/2. The period is equal to 2 pi over b. And here, b is this number in front of the x. So the absolute value of 2 pi is 2 pi. So 2 pi over 2 pi is just 1. So here the period is actually just 1. The amplitude is 1/2, and the period is 1. Now that we know that, we can find the 2 x-intercepts. Let's start with the x-intercepts. The 2 x-intercepts are going to be here and here. So the first one is 1/4 times the period, 2 pi over b, which is the same as the period, so 1/4 times 1 equals 1/4, comma 0. And that comma 0 is just from right here. It's always going to be comma 0 because it's the x-intercept. It's 0 on the y-axis. The second x-intercept is going to be 3/4 times the period, or 2 pi over b. So that's 2 pi divided by 2 pi, or 1, just times the period, is 3/4, comma 0. That's the second x-intercept. Now we're going to find our 2 maximums. And the first one is 0, comma a. And here a is 1/2, so the first is at 0, comma 1/2. And the second one is at 2 pi over b, comma a. So 2 pi over b, which is 2 pi, once again, 2 pi over b is just the period. So we're going to have 1, comma a, again, which is 1/2. The last thing we're going to do is find the minimum, which here is in green. So to find that, we do 1/2 times the period, 2 pi over b, which is 1, which is 1/2, and then it says comma negative a. Negative a is going to be negative 1/2. So here are the 3 points we're going to use to draw, or the 5 points, the 5 points we're going to use to draw a graph. Now while we're drawing a graph, we have to ask ourselves some questions in order to help us graph it, and this is really just common sense. So the maximum height on the graph is 1/2. So this graph only needs to go up to 1/2. I can draw it up to 1 just to show that, but the highest point is going to be at 1/2, and the lowest point is going to be at negative 1/2. That's the lowest y value on the graph. Now let's look at the x values. We have 1/4, 3/4, 1/2, 0, and 1. So on our x-axis, we're going to need 0, 1/4, 1/2, 3/4, and 1. And now we can just plot our points. So the first point, well, it doesn't really matter. We can just go through it. So there's one point at 1/4, 0. Give me some different color. There's a point at 1/4, 0. 3/4, 0. There's a point at 0, 1/2. There's a point at 1, 1/2. There's a point at 1/2, negative 1/2. And then we can just draw our line through it. That's what our graph's going to look like. Of course, we could keep this going forever and ever. It's just going to continue like that. But we only need to draw the part directly in the middle.